116. We are going to be clearing fractions today, which means that we're looking for a number that matches both of the bottom fractions. We want to make them happen. So it says, which number is a multiple of both 6 and 8? Mac. You're close. You went the other way. So you kind of went to take out a greatest common factor. We're looking for what's the smallest thing that 6 and 8 both go into.
Is that like the number that's next, or
18? 18 doesn't have 8 go into it. 24. Okay, so this is like 6 times 1 is 6, 12, 18, 24. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Do you see how that's the first time they match? So what we're going to do is we're going to multiply both sides by 24. Those of you who are in my classroom, I can tell you can't see that this is a line. So I'm putting that in. It should be on your paper, though. So when we see fractions, we're like, fractions! They're so scary. And that's okay. We're going to get rid of them. That's the whole point of today, is every single time we're going to go get rid of these fractions. So I'm going to multiply by 24 on both sides. Why 24? We chose 24 because that is the next thing that happens. It's called an LCD, the least common denominator. Okay, so 6 and 8 both go into 24. We're going to multiply by 24 to clear that out. When I do so, the 6 on the bottom is going to go away, and the 24 changes into something different. The 24 on the 6's side changes into a 4. On the 8th side, the 24 changes into a 3. Can you tell me why? Because 6 times 4 is 24, and 8 times 3 is 24. So we kind of did 24 divided by 8 made this 3. 24 divided by 6 made this 4. That's what we end up getting to multiply on each side. So I've got 4x equals 3 parentheses x plus 1. Please notice that I didn't just put the 3 at the end. Please notice that I added parentheses around what was originally there, and that I put the 3 in the very, very front to represent multiplying or distributing. Questions? What? Right. So now we're going to solve like normal. What do I need to do in order to solve this normally? Go ahead and distribute. When I distribute, I get 4x on the left-hand side. It's still the same. I get 3x on the right-hand side. And then I get 3 times 1 makes positive 3. We're going to solve like normal, which means we're trying to get x's by themselves. However, we've got a big problem here first. What's the big problem? There are x's on both sides. So we want to take care of those. We want to move them all to the same side. Would you like me to move the 4x or the 3x? Why would you like me to move the 3x? There's a couple of reasons. It's smaller. So it's easier for us to move that over to here. Why else? There's one really scary reason. Not to get it away from the 3.
It's because there's only one thing on the left side.
Because there's only one thing on that left side. We don't want to cancel out that left side if we can help it. We want to leave that left side having something and the right-hand side having something. So I've got 4 minus 3 gives me 1x. What's on the right-hand side? Is there anything else I need to do in order to solve this? No, but if you love your math teacher, you'd box your answer. Okay, our book asks us to check our solution. We are not doing that today. So we're going to number 4. We're going to do the same sort of thing. I've got a 2 on the bottom. I've got a 6 on the bottom. What do both 2 and 6 go into? 12. There's something lower. 3 go, 6. Okay, so this one's a little strange. It's nice and easy because one of our numbers is the highest, like the lowest common denominator. So I've got 2, 4, 6, and I've got just 6. That's where they meet the first time. So I'm going to multiply by 6 on both sides. When I do so, my 6's just cancel. I could put a 1 there, but I don't have to. What happens to my 6 on the left-hand side? Not out completely. It turns into a 3. You can do that a couple of ways. You can see that this is 1, 2, 3 down, or you can know off the top of your head, hey, 3 times 2 makes 6. I'm going to rewrite. Notice that I had to put parentheses around the x plus 4. It was originally there. You put parentheses around it. I don't need it on the right-hand side because my 6 is totally canceled out. Now what? Distribute. When I distribute, I get. Okay. My goal of every single problem is what? To get the x alone. What's a problem? There's 2 of them. So we're freaking out a little bit. What do I do with these 2 x's? I need to kind of combine them together. We don't want to say combine like terms because that only happens on the same side. So what do I need to do with one of them?
Make it a positive.
I need to make one a positive and move it over, right? So in this case, I'm going to make the 2 a positive and move it over. That's the easiest one for me. It cancels on the right-hand side. 3x plus 2x gives me. I can rewrite plus 12 equals 7. Now what would you like me to move?
12.
I'm going to move the 12 next because the 12 is farthest away from the x but still on the same side. I'm going to scroll this up a little bit just so that those of you in my classroom can see all the way at the bottom. How do I move the 12? Add, subtract, multiply, or divide? Subtract. When I minus 12 on each side, it cancels on the left, and I'm left with 5x. What do I get on the right? Okay, I ran out of room. What happens when you do that? You're going to move it. I've got 5x equals negative 5. Now what? I'm going to divide. So I'm still trying to get x by itself. It's hanging out with a 5 right now. I've got to get rid of that 5. I'm not going to subtract the 5 because it's right there. It's right next to that x. So I like to say that they're kind of married. And in order to separate them, they need to get a divorce or they need a door put between them. I like that all of those start with D. Divide, divorce, door. The 5's on the left-hand side cancel, and I'm left with negative 1. You're going to go ahead and box that answer for your wonderful math teacher. And now you are going to try 5 on your own.